I'd like to give a brief introduction to linear equations. So first, a linear equation is something where the variable, usually x, but it could be any letter, where the variable doesn't have any exponents or square roots on it. So just an x, or maybe a 2x, or maybe a 5x. Those are linear terms. So a linear equation is something where we only have linear terms of the variable. So I've got a big list of equations, and the question is, which of the following are linear equations? The first equation in my list, 3 minus x equals 7, is an example of a linear equation because the variable x is linear. It doesn't have any exponents or square roots. Whereas the second equation listed is not linear, and that's because the variable has a squared on it. So this is actually a quadratic equation, but for our purposes, the important thing is this is not a linear equation. The third equation on the list is also linear. The x appears in multiple places, but it never has any exponents on. We have linear terms of x in this equation. And finally, the last one is not linear, and that's because it has a square root in it. So square root of x would not be a linear term. All right, so our goal is going to be solving linear equations. And when we solve a linear equation, when we try to find a solution, we're finding a number that if you plug it into the equation, it gives you a true statement. So in this next example, the problem says, is x minus 3 a solution of the equation 4x minus 9 equals 2x? One way to determine if a value is a solution of an equation is just plug it in and see what happens. So I'm going to take my linear equation and I'm going to replace both of these x's with 3's. So now I've got 4 times 3 minus 9 equals 2 times 3. So I took the number given, plugged it into the equation. Then I'm going to simplify each side and check and see if they're equal. So on the left, I get 12, 4 times 3 is 12, minus 9. The right side, 2 times 3 is 6, and notice 12 minus 9 is 3, and 3 does not equal 6, so x equals 3 is not a solution of this equation. For a number to be a solution of an equation, you have to get the same number, you have to get a true statement when you plug it into the equation. And so we're going to be focusing on how can we find solutions of linear equations. And so we're going to take advantage of two different properties of equality today. First, let's learn the addition property of equality. So this says if two things are equal, if A equals B, so if we have a statement of equality, we can add the exact same number to both sides, and the statement is still equal. Now, this is called the addition property of equality, but you could also subtract the same number from both sides, because that's just like adding a negative number. So let's see how this works with some examples. If we want to solve the equation x minus 4 equals 24, our goal is to get this x by itself. So we want to get rid of this minus 4. The opposite of a minus 4 is plus 4. So I'm going to add 4 to both sides. And that's going to isolate the x or get the x by itself on the left-hand side. So if I add 4 to both sides, the left-hand side just becomes x because minus 4 plus 4 is 0. So we're just left with the x. And on the right-hand side, 24 plus 4 is 28. So my solution is x equals 28. Now the nice thing about solving these equations is we can always check our answers. We can take this x equals 28, plug it into the original equation, 28 minus 4 equals 24, and this is true. 28 minus 4 is 24. And so that's a great way that I can check and verify that I've done the problem correctly. Here's another one. M plus 6 equals negative 14. We want to get rid of the plus 6, so we have to do the opposite. This time I'm going to subtract 6 from both sides. The 6's go away on the left. I'm just left with m. Minus 14 minus 6 is minus 20. And there's my solution. M equals negative 20. Now there's a second property of equality called our multiplication property of equality. If we have an equal sign, a true statement, A equals B, we can multiply both sides by the exact same number, and the statement is still true. Now, again, this is called the multiplication property of equality, but we can also divide both sides by the same number, and we still get a true statement as well, because dividing by this unknown number c is the same thing as multiplying by 1 over c. So this works for multiplication or division. All right, how does this work with an example? Here's an equation. 5 times x equals negative 35. I want to isolate the x. I want to get the x by itself. I have to get rid of the 5. Notice in this problem, there's no symbol between the 5 and the x. That means they're being multiplied. The opposite of multiplying by 5 is dividing by 5. So I'm going to divide both sides by 5. And then what happens is 5 divided by 5 is 1. And so the left side just becomes 1x. The right side, negative 35 divided by 5 is negative 7. And that's my solution, x equal negative 7. Here's another one, negative x equals 7. Technically, there's a negative 1 in front of that x. The negative 1 is being multiplied by the x, so I'm going to divide both sides by negative 1. Minus 1 divided by minus 1 is 1, so I'm just left with x, and 7 divided by negative 1 is negative 7. And there's my solution, x equal negative 7. Let's do one more. Last example says x divided by negative 3 equals 7. We have the same goal. We want to get that x by itself, so I have to get rid of this negative 3. The x is being divided by negative 3. The opposite of division is multiplication. So this time I'm going to multiply both sides by negative 3. This allows me to cancel the negative 3's out on the left. Technically what's happening is we have this negative 3 divided by negative 3. That gives me a 1x. But really you're just doing the opposite. Because we have division, we have to multiply both sides by negative 3. That gets rid of the negative 3's on the left. So now we have x equals 7 times negative 3, which is negative 21. And there's my solution. Again, we can check our answer. We can take that negative 21, plug it in for x, and negative 21 divided by negative 3 is equal to positive 7. And so because that works out, that tells me that I've done the problem correctly. That was my last example. We're going to pick up on linear equations in the next video. In the meantime, please reach out if anything is unclear.